Hi guys, Mr. G here. I just got a few comments that you guys would uh, uh, prefer to see the person behind the voice. So I won't do this regularly. I'll just do it once in a while, where maybe I'll show the video so that you guys can see me. However, I think it's more important that you get what I'm saying, you hear what I'm saying, and see what I'm writing more than seeing the person, who's doing all the talking and all that. But overall, this is who I am, and yeah, I'm a maths teacher, passionate about maths education, and that means really the objective of my teaching is not to show how much of the math I know. It is just to explain the math in the most simplest way that you can understand and everyone can understand. And I really hope that you guys are finding this helpful and you have been finding this helpful. And it's my desire that you will go out there, write your test with confidence, with thorough understanding of the mathematics, the correct language, the correct thinking, and of course the correct grammar, writing. In other words, how you write your fractions, how you use the different symbols that are there in math. So that's really my objective why I'm doing this, so that you enjoy math, you know why you're doing math, you take math as something that becomes part of your nature. It isn't just something that you just cram past because you want to be an engineer or a medical doctor, but you understand really the thinking behind the mathematics, why we do things. It's one of the important questions actually that you've got to ask. Always ask why. Where does this come from? Why am I doing this? If you would get yourself into this habit of asking, I think you will find maths much interesting, than it is at the moment. So let's get to the business for today. I just want to look into trig identities, two main identities that come as a result of the triangles that I've been showing you guys here. So I'm just going to prove them quickly for you, and I hope you are able to follow through and actually see that for yourself. It's just one. One is the quotient identity, sin theta divided by cos theta is the tan of theta. And the second is the square identity, sin squared theta plus cos squared theta is equal to 1. So that's what the objective of this video is, to quickly prove those identities. I really hope you enjoy. Pardon me, I'm going to switch off my video and show you my screen as we get to business. Right. So far, I believe we are familiar now with the Cartesian plane and setting up triangles on the Cartesian plane. So not surprising that I'm going to do exactly that here. So I'm going to set up my right angle triangle, and I'm going to use this triangle to prove both identities. And I hope from this you also learn how to structure a proof in mathematics. This will really go a long way, because from this moment going onward, in trigonometry, you're going to have things to prove. In geometry, you already know you've got stuff to prove. So yeah, my right angle is not that perfect there, but let me not bother so much about it. So let me call this angle here of mine, well, let me call it what? Alpha. Yeah, let me use alpha this time. Okay, this time around I'll use alpha. You'll excuse me, my computer is just acting up a little bit here. Not sure why. Nonetheless, so yeah, I was saying, let's have this angle here. All right. Oh, my bad. Yeah, My, my pen was upside down. That's why I wasn't winning. Right? So that is beta. Now, we know, I mean, that's the y-axis. This is the x-axis. So this side should be y. That should be r, the hypotenuse. And this should be x. We're going to use Pythagoras basically to prove the square identity. As for the quotient identity, it is very simple. So by definition, the ratio sine of theta is opposite, which is y, over hypotenuse, which is r. And the ratio cos of theta is adjacent, which is x, over r. The ratio tan of theta is opposite, y, over adjacent. In case you are wondering, may I just remind you of this acronym, SOHCAHTOA, or some say SOHCAHTOA. I don't know. As I said, for me, pronunciation is not a big deal. It just depends on which part of this world you're coming from. Right? Okay, that's just on a lighter note. Let's go for this. So our objective is to prove RTP means required to prove that sine theta divided by cos theta is tan theta, right? So we want to show that the left-hand side here, LHS, is equal to the right-hand side. So I'm going to use those definitions to prove this. So let's go. I'm going to take first, what is sine theta there? The sine of theta is y over r. Now, instead of having this big fraction, I'm just going to use the division sign. Cos theta is what? X over r. And then by the basic rules of fractions, fractions are arithmetic, I'm going to have to multiply this by the reciprocal, and that's what I have. And you realize here again, actually r will divide r, then I'm left with y over x. But what is y over x? It is actually tan theta. And so that is the end of the proof. Yes, that easy, that's straightforward. The next proof that we're going to prove is what we call the square identity. This one is called the quotient, if you think about it, because we are dividing these two, so division is known as quotient. Now this one is called the square identity, and you will see why it is called the square identity, because we are saying the square of these two ratios, okay, not the square of the two ratios, sum of the squares rather, yes, is 1. So the ratio sine of theta squared plus the ratio cos of square theta squared will be 1 in any right angle triangle. So again, we must prove, we are required to prove that this thing on the left hand side is equal to this thing on the right hand side. If you think about it, we can't do much to the one. Of course, in Trig, you will see this when you get to grade 11. This is just to entice you, to appetize you, so that when you get in grade 11, you do not panic. You see that actually these proofs are very easy. In grade 11, we deal with identities. We prove a lot of identities. And by the way, these two are also identities, okay? So they are very simple. So this is just to entice you. So what is sine theta? Again, sine theta is y over r. So we're gonna go ahead and square that. What is cos theta is x over r. We're gonna go ahead and square that. And notice I am not going to write here is equal to RHS. No. I'm gonna work this out until it is equal to RHS. So actually here I should have said RHS also. That is not it. It's immaterial really, but just for to internalize this for you at your level, I'll recommend you do that so that you get a sense of what you're doing. So what's happening here? I hope you are very okay with your algebra at this point. You see, I've got that y squared over r squared plus x squared over r squared. But we know that when we have fractions and the denominators the same way, you can simply what? Add up the numerators. So that's exactly what I'm going to do here. But wait a minute. In this triangle, what is x squared plus r squared? Well, Pythagoras tells us that x squared r squared plus y squared is r squared. And therefore, I've got here r squared over r squared, and this is 1. Oh, this is what I wanted to prove. That's the right-hand side. And so, yep, that's it. Bravo. We are done. We have made it. We have proved that sine squared theta plus cos squared theta is equal to 1. And we have also proved that sine theta divided by cos theta is equal to tan theta. So this is just, as I said, to introduce you to the idea of proving in trigonometry. And I hope you like this. I hope this is comprehensive enough. And I hope you can probably try this on your own, see if you can do it. See you in the next video. Well, I won't see you, but we meet again there when I'll be talking quickly about the angle of elevation and depression. Thanks for watching. Keep supporting. If you haven't subscribed yet, please do so. Cheers.